Everyone, I am Satyapriya, Assistant Professor, Department of Physics. Now we are going to discuss about the topic case study on superconductivity, revolution and then energy transfer. Explore how superconductors are said to transfer our world, enabling efficiency in energy transformation and beyond. Now briefly discussed about these superconductors. What are the superconductors and then key properties and then definition. Superconductors are material that conduct electricity which absolutely zero resistance when cooled below a critical temperature. This unique property allows high efficient energy transfer without any loss. Zero electrical resistance, no energy lost as heat during current flow. And then Meissner effect, expel magnetic fields. In this case, the material does not allow the magnetic lines of flow. That is called as the Meissner effect. Very important point in this superconductor is Meissner effect. Obey the Meissner effect. And then critical temperature, each superconductor has a specific temperature below which it's operate. And the next one is historical development. From discovery to modern application. In 1911, discovery, the Heike Onnes discovered superconductivity in mercury at liquid helium temperature. This is the first discovery of mercury. And then next one is 1933, Meissner effect. In this case, Meissner discovered magnetic field expulsion. And the next one is 1986, high temperature superconductors, discovery of ceramic superconductors operating at high temperature, more high temperature. And then last one is at present practical application, development of technologies for MRI, power grids and advanced computing. These are the historical development from discovery to modern applications. Okay, next one is the case study the ITER fusion reactors superconducting magnets. In this case, ITER, the full form is International Thermonuclear Experimental Reactors. In this case, massive superconducting magnets to confine superadhered plasma for fusion reaction. These magnets are among the largest and most powerful ever built, crucial for clean energy future. And then record breaking size, TF coils are 360 tons for each. And the next one is extreme condition, operating at just above absolute zero yet containing plasma hotter than the sun. And the next one is energy, a step towards commercially visible sustainable power. These are the case study, the ITER fusion reactors. And the next one is challenges in superconductor implementation and operation. In this case, cooling requirements, maintaining the critical temperature often require expansive and complex cryogenic systems, limiting widespread adoption. These are the cooling requirement. Next one is material requirement, and then next one is fabrication complexity. First, second one is the material cost. High temperature superconducting materials can be costly to produce and process, increasing the initial investment. That is the material cost. And then fabrication, the manufacturing long flexible wires or large components from brittle superconducting ceramics is technically challenging. Okay, next one is future application and then transportation, medicine and computing, and then magnetic levitation train, advanced medical imaging, and then quantum computing, and then superconducting power grids. These are the future applications. And the next one is conclusion, and then conclusion, lesson learned, and next step in superconducting research. For example, superconductors offers a profound, and then for example the journey into the superconductors reveals both potential and the formidable challenges, and then continued research particularly in higher temperature materials and then scalable fabrication is essential. For example, and then key takeaway in this case of case study point is zero resistance, and then crucial for next gen technologies, and then significant economic benefits, and then next step in invest in material science, and then world pilot real world applications. These are the my case study on the topic in superconductors. Okay, thank you.